Hey guys, so just if there's any noise, it's my son, right? He's right here with me. So I want to do FRQ one, right? I want you guys to focus on the easiest FRQ from all four, right? So again, each FRQ is 4 points, right? So on this one, you're gonna get 3 different topics, right? You're gonna have part A, B, and C, right? So let's try to break this problem together. So the function h here is defined by h of x equals g of f parentheses x, right, equals g of f of x, right? Find the value of h of 1 as a decimal approximation or indicate that that is not defined. So here we have a composition of functions, right? So we have to start off with this right here, h of 1, right? So h of 1, if we go based on the format that they gave us, right, we have to replace the input x by 1. That means this one gets replaced by 1. And this one also gets replaced by 1. So composition of functions. Which one do we start? Alright? So you focus on f of 1. So here we go. F of 1, there's 2 different functions. You have the table, which is focusing on the f of x, and g of x, which is focused over here. So f of 1, you focus on the input of 1 for x, and then you have f of x, right? So what do they meet? They meet at an output of 6. So now you have g of, well, basically 6. So now what do I do with that? Well, technically, you go back here to your second function, g of x, and just replace the x by, well, basically 6, right? So 2 ways to solve this, right? First one, or I'll just do the main one, right? You could literally, since you're allowed to use a calculator here, you could literally just go to a regular calculator and just replace every x and input that 6, right? So if you do that, you get negative 39.4. So we're just gonna basically do that. So go to the calculator, right? Because you're allowed to use a calculator, and that is basically it. So here, h of 1, so the answer would be h of 1 has a value of negative 39.4. Literally, it's that simple, right? So now it says here, on the second section, find all the values of x for which f of x, notice how now we're focused back on f of x, is equal to an output of 4, or indicate that there's no such value. So now, f of x is this table, so if I can scratch this out real quick, right, and just get to this here. Focus on the output of 4. The output of 4 is, well, the y, right? This is your y. Technically, this is your output, and x is your input. So you have a 4 right here, but that's not the only 4. You also have this 4 right here. So what are my values? Well, you can say that f of 4, you can say that x is equal to 2, and x is equal to, well, basically 5, right? So they gave you the y, find the x value. So here you have 2 solutions. You have x equals to 2 and x equals to 5. And that is literally it. No other thing. Just focus on that. Alright? So what about for section B? On the first part, find all the values of x as decimal approximations. And you know this is 3 decimal placements, 3 numbers after the decimal placement, right? For which g of x equals to 5. So now, they gave us an output value, but the output value is given for g of x. So now here, when you're doing this, where g of x has a value of 5, literally, it's this. So, how can we tackle something like that? Well, if you go back to your calculator, because you're allowed to use it, you could, if you want to, you could literally graph it. If I graph it, it should look a little something like this, right? Just in case you guys are wondering, how did I graph it, right? Literally, I'm just gonna copy it real quick, right? You're literally gonna copy it down, or for myself, right? You guys have to write this down now completely. Press enter, right? You're gonna start out with something like this, right? Let me erase this real quick so you guys can visualize it. So here, right, this is the equation that we're graphing, right? What I can do is that I can go to menu, right? So I can analyze this a little bit better, right? Press on 6 and just, go to the zoom, right? Because I want to zoom out. So go here and This is literally your graph, nothing too fancy, right? But I want to find the output of 6, so what could I do? Well, you're allowed to graph, so put another function, right? But this time the function has a value, an output value of 6, right? So your focus here, where do they intersect, right?
It's an output of 5.
Oh, sorry, it's an output of 5. My bad. Thank you. It's an output of 5. So here you go, right? So where do they meet? Well, they meet where? They meet, if I do tracer, right? Menu 5-1, right? If I start over here on the right, they meet over here at, what do you call it? I cannot get it. Sorry. What could I do? Stop it?
No, you could do menu.
I can do menu? Thank you. So I'm gonna do menu.
6.
Menu 6.
And intersection.
There you go, that's the one I wanted. I just
Before and after.
Yeah, before and after. So look, they're always showing here. So one of them is 9.82. If I do menu 6, if I do menu 6 again, right?
4.
And 4. I know I just blanked out. I know, Leo. Oh no. If I go back over here, I also get 1.41, and there's another one. So if I press menu and then I go again, right, and go to 4 and get this last one, here it is, right? Oh, this one's a little too close. There you go. The last one's negative 1.24. Okay, so these would be all my solutions for that output value that was given for g of x. So again, g of x, the original equation is this one in green. And then the value for g of x that they gave us is, well, it was 5, right? So you're gonna notice that all my outputs, all my y's are 5s. I'm looking for all my inputs, negative 1.24, 1.41, and 9.82. I believe that is it for that part, right? So, yeah, just keep that in mind, right? That is B1, right? What about B2? These are my favorite ones because you guys master these, right? End behavior. Here, end behavior is focused on g of x. So my focus here is not the table, but it's the function, right? In this case, it's a polynomial. So in this part, I always told you guys don't have to graph this. Although we already did, you guys don't have to graph this. All you guys have to do is just look at your leading term. Remember? So the leading term has a degree of, well, green, that means it's odd, right? And then this number right here, I don't care what number it is, right? I don't care if it's super big or it's a decimal. I don't care. I only care about the sign. There is no negative sign here. So therefore, this number is positive. So we have a positive polynomial that's odd. So how do I figure out? This is the one where one side goes up, the other one goes down. How do I figure it out? Well, remember, I always told you guys, if you have a question, ask your teacher. Pick up the right side, right? So the positive odd is going to be the right side being going up. So you're going to get a little table going like this. And then it's going to basically go down, up the right side, and then the left side goes down. So what's happening here? So if I continue reading, right, determine the end behavior of the limit. So limit notation, right? So limit notation is this. Limit as x approaches positive infinity. So what happens when x goes to the right? What's happening to my y? Well, my y equals positive infinity. But if you write it like that, there's an issue. Oh, that looks like a g. This should be a y, right? If you notice that, this is wrong because my focus is g, right? So this little section, instead of being y, it should be g of x equals positive infinity, right? And the same scenario goes, right? In this case, it just told us determine the end behavior of g as x increases. So that's why we're going with x approaching positive infinity. What happens if they mention decreasing here? Well, my limit would be focused on the left side. So my limit as x approaches negative infinity because now we're decreasing. X is decreasing to the left. So what's happening to my y? My y, which we already said, we're not going to call it y, we're going to call it g of x. This is going to be g of x approaching negative infinity. And that's basically it, okay? Besides that, let's look at part C. Part C tells me here to determine the inverse. So when it comes to the inverse, you have to remember, right? I have to switch X and Y. So do I focus on F or do I focus on G? So here, it tells you right here, I want to focus now on F. So basically I go back to the table and now I'm here. So all these Y values are now going to become my inputs and all these X values are going to become my outputs. So if this bottom part goes to the top and this top part goes to the bottom, you're going to notice that, hey, does this have an inverse? And the answer is, well, basically no, because now my inputs are going to be repeated. My inputs are repeated. So literally, the way you can answer this part is just say yes or no. And here the answer is no. Later on, we're going to try to expand this section right here, right, and actually put it into a sentence. But for now, if you give me yes or no, I'll give you credit, right? So the answer is no, because if this becomes my input, the input repeats. So there is no inverse. So it tells you here, now here's where you have to explain. Give a reason for your answer. So why am I saying no? Well, I can literally say that, hey, my input is repeated. So input, if I take F, right, and apply the 4, the input of 4, right, I'm going to have two values for my output. I'm going to have an output of 2, and I'm also going to have another input of 4 repeated, right, because there's 2 of them. The other one's going to be 5, right? So again, give a reason for your answer based on the definition, right? For now, also, if you just show me this section right here, I'll give you credit. Eventually, we're gonna have to start writing it into a beautiful sentence, right? But for now, we'll just leave it like that, right? Give a reason for your answer. You can put the -1 because we're talking about the inverse, right? So don't forget about that. With that being said, that's basically it.
Stop.